Hello and welcome to the first module in the Aldous Academy training for the Leviton Security and Automation system. This module is the first of a series of modules which will take you through a good understanding of the system, which is what we call part of our Part 1 training. It is then followed by a Part 2 training course, which is a hands-on training course run out of our office, where we take you through hands-on building and programming the system in all the components that we cover in these online overview tutorials. So we'll get straight into it. First of all, the whole one of the unique things about the Leviton Security and Automation platform is it really is a true building control solution. It actually includes and Leviton manufacture the various components that go into building control, including lighting control with all the dimmers and light switches, and heating control with thermostats and temperature sensors, door entry, keyless entry, door access control, video intercom, multi-room audio, and then there's just lots and lots of outputs where you can pretty well control anything. And compatibility with motorized blinds, motorized curtains, motorized door openers. It truly is a full building control solution, which separates it from some of the other systems out there that are really just a control layer, and then you need to integrate third-party products for the thermostats and the dimmers and the door entry, whereas with the Leviton package you're getting the whole thing from one manufacturer, which guarantees the interoperability and reliability that you kind of need from these sorts of systems. Can be used both residentially and small commercially, and provides a user interface via either their own dedicated 7-inch touchscreen or from smartphones or tablets, and indeed the system also has integration with other control systems, such as, you know, if your customer's already got a Crestron or a Savant or RTI, URC, many of the control systems that are out there, we've got drivers to be able to integrate with. So it's a very comprehensive solution, and really there's no project that it couldn't be possibly integrated into. So very, very flexible. But some of the key things that I think really stand out with these sort of home automation systems that really has benefit to end users. One of the key things that I certainly have quite an interest in is energy management, being able to actually save your customer money, and simply by zoning up the house and controlling each zone independently, so rooms that aren't being used on a regular basis can be set at a lower temperature to save energy, and being able to set back the thermostats when the alarm is armed in away mode. You can set the thermostats back to save energy when you're not there, or simply being able to set the heating back low when you're away for a couple of days, but still be able to turn the heating back up from your smartphone on return, so the house is nice and warm when you actually arrive at the front door. Convenience. We are moving to an era now where people really ask, why can't I do it from my smartphone? People have become so used to the concept of apps controlling just about anything and everything. It seems almost illogical that you can't control the key features of your house from your smartphone. And that certainly is something that this platform can enable. And being able to just launch whole house functions, when you go to bed at night, have a single button, you press that button and that might arm the alarm downstairs, that might turn the audio zones off, turn the lights off, set the heating back to nighttime temperatures, all at the single click of one button. Certainly has a very, very powerful, and gets users to do things that, quite frankly, they perhaps wouldn't bother to do, and they might just leave their thermostats on normal temperature the whole time. Whereas you make it easy for them, it makes it easier for them to actually save money. But also very important is enhanced security. The Leviton platform is the only home automation platform on the marketplace that has a fully integrated intruder alarm, which is fully compliant to the UK regulations for police response. And that really does have some very nice capabilities, because integrating home automation with security gives us a lot of information. We know, for example, when the house is empty because the occupant has armed the alarm in away mode, so we can make decisions and do sensible things based on that information. We know when the user comes home, because they disarm the alarm. We know who disarmed the alarm, so we might set the house up to different preferences based on who disarmed the alarm. And then the whole house is full of sensors, door sensors, PIR motion sensors that can all also be used as part of making the home more intelligent, and being able to do things for the user automatically, because we can sense occupancy, we can sense when doors or windows open, and do intelligent things. So it's a really nice integration of getting the security integrated into the home automation. It really opens up a lot of doors in terms of the sorts of things you can offer. So let me just talk a little bit about how automation tends to work. This is what we call event-based automation. So this is where really the control system is triggered to do things based on events. These events could be, for example, a door opening, or it could be a timed event at certain times of day, there's all sorts of things that may trigger these sorts of automation that we can program. Some examples are here that, when the front door opens, turn the porch light on, the first one here, actually, I beg your pardon, is time-based, is actually at sunset, turn the porch light on, and at midnight turn it off again. The second one down is turn the light on when I enter the front door, so that's triggering off the front door is the event that triggers the actual automation. Maybe send an email when your child comes home from school. So again, the event here is the trigger is the child entering the disarm code, and then the automation might then send an email to the anxious parents just to let them know that their kids got home from school safely, because they may not be home for a little while yet. And, turning lights on is a great one. If someone walks through a dark hallway, the motion sensor will pick it up. And if the lights are not on already, then perhaps turn some of the lights on to sort of 10-20%, to give them some orientation lighting. These are all nice things that we can do. But these are all based on events that are happening there, or we call them triggers, that have a consequential action. We also have what we call button programming, which is where a user initiates something themselves, where they basically press a button. And these may also be known as macros in our industry. So someone presses a button and we do multiple things. So a go to bed button might turn the lights off, arm the security in night mode, set the thermostats back, and turn all the audio off. You might have a button for the morning mode when you wake up that sets the house up how you like it when you get out of bed, or a dinner party or a romantic evening, or these are kind of whole house scenes that may involve the lighting, the heating, and the audio and the security settings, and anything else you like, the motorized blinds, shade coverings, motorized curtains, those sorts of things. So there's two things that typically we use to sort of trigger automation and make homes more intelligent: event-based and button-based. A little bit about Leviton. Leviton is a fairly interesting company. They are actually over 110 years old, massive history. In fact, date right back to the Thomas Edison days, where Mr. Leviton actually helped Thomas Edison electrify New York. He actually manufactured the little bayonet that Thomas Edison's light bulb fitted in. And so huge heritage, and approximately a $1.5 billion corporation. They're basically the electrical manufacturer in the US. This is a picture of their head office in New York. And the Leviton LS&A system dates back to what was previously known as the HAI system, which has got hundreds of thousands of installs all around the world. They're shipped to 80-odd countries around the globe, and massive presence in the US. But obviously Leviton, being a very big corporation, has multiple business units covering commercial networking solution, residential light switches, data center infrastructure, over 25,000 products across the whole portfolio. The Leviton Security and Automation is set up as a separate business unit within Leviton as a corporation, and that's the thing we're going to focus on here today. But nice to know it's backed up by a big company that's probably going to be around probably a lot longer than I will. So I'm going to dive in now and focus straight in on the hardware on the main Leviton Security and Automation controller. There are actually 3 controllers to fit any size project. Starting at the top, there's the Omni Pro 2, which is the biggest controller that's got the most capabilities. All 3 controllers actually are all the same hardware. And there are software limits basically in size of the project in terms of number of thermostats, number of lighting circuits, number of security zones, those sorts of things, and the price is set on each of these controllers accordingly in order to allow you to compete in the marketplace. But rest assured, it's the same hardware. You cannot upgrade from one to the other software wise. Once you've bought the controller, that's it. It is that one for life. If you're in doubt, always quote a pro, because you never know what sort of requirements your customer's going to have or want to add for expandability. But if it's a very cost sensitive project and it's 30 properties or apartments in an MDU development, then obviously that's where the LTE comes in for giving you a really low cost platform. So that's the 3 controllers that are available to you, and as I say, they vary in terms of quantities, basically in terms of things you can connect to them on the overall project. Just looking at the actual controller hardware itself, it's dedicated hardware manufactured by Leviton, absolutely bulletproof. It runs 24/7 reliability. It's just not something you ever have to reboot or worry about it going down, because it's come from that building control ideology where it just runs all day, every day, 365 days a year. Just giving a quick whirlwind tour, starting up here on the main controller hardware. We've got 5 RS-232 ports, which actually can double up as RS-485 ports. There's a little jumper underneath that can convert them between RS-485 and RS-232 for connecting to various things. For example, communication with the audio system is via an RS-232 link between the two, connecting to various third-party things. Connecting to the the access control reader is actually RS-485. RS-485 has the benefit of being able to have very long cable runs, so you can connect from here to up to 64 access control, 16 access control card readers. Over here I have an Ethernet port for connecting to the network. Believe it or not, there's actually still a legacy X10 port on here from back in the day when X10 was a state-of-the-art technology, very, very rarely used nowadays. There is an expansion port here where you can fit daughter boards onto the main controller to add more zone inputs, and an additional RS-232 port, in fact. Then we come to these connection strips down the bottom here. The bottom one are all zone inputs for the intruder alarm. So this is where you'll connect your PIRs, door contacts, smoke detectors, those sorts of things. Indeed, you can connect anything here that provides a vault-free contact closure that you want to trigger from. It could be a push-to-make button, which will then trigger an automation task. So these, I look at these as inputs. Just up here, I've got 8 outputs, which basically I can put 12 volts output from here to perhaps trigger a relay or switch a 240 volt relay. So these are outputs that I can use to control things. Just over here is a telephone dialer. It's got a built-in dialer for connecting to the telephone line, so the system can dial out, and has actually got its built-in speech dialer, so it can dial out and speak to you, and you can program it to tell you things. like you know, the AC power. You've got a power cut and the AC power's gone off, and yes, it will still work because it's battery backed up. So that's pretty useful to know if you have a power failure in your home. And of course, for the intruder alarm, if the alarm goes off, the system can dial up and talk to you and tell you that your burglar alarm's going off and which zone has been triggered and that sort of information. Just over here, I've got connections for the keypad. There's a keypad that's part of the alarm system, and also I connect expansion enclosures from here as well, where I can have more and more zone inputs, up to 192 zone inputs on a Pro. Over here I've got some general purpose 12 volt outputs for powering things such as PIRs and smoke detectors and the like. And just over here I have the main 24 volt AC power input for the controller and a earthing point. So that's just a quick tour of the actual controller hardware. Some of the things you can add as hardware expansion. We have a very nice little board which is called the two-way voice module. It basically can connect to the main controller on one of those expansion ports, and it actually gives the control system the ability to make announcements. You've got some audio out. We've got 2 speaker level outputs here. You've got a line level output that can connect to the hi-fi audio system, and it can make announcements through the speakers. So if you've got a visitor pulls up in the driveway, then it could make an announcement to say there's a car in the driveway. There's also some security applications here as well, where you can make sort of audio challenge if you connect these speakers up externally. There's some external trigger which has detected an intruder. You could have some announcements challenging, you know, informing the intruder that this is a secure area and you have been detected and the police are on their way. So you've got that audio output. You've also got microphone inputs as well. This is also from a sort of security as well as a care type application, where a monitoring station can then listen in and hear whether or not what's going on, and especially if there's a duress code has been initiated because the occupant's under duress, then the monitoring station can listen in, and you might have some key words to let them know that you're actually, you know, got a gun to your head and you can't say help, but you might have some key words that you've agreed with the monitoring station that indicate you're in trouble. Or care at home applications where maybe an elderly person has pressed a panic button, and then the monitoring company can listen in and hear what's going on and actually speak through the speakers to let them know that someone's on their way. So quite a few nice little applications that this expansion board can provide for you. This is an RS-232 expansion card that fits in the top right hand corner of the main board to give you an extra RS-232 port. And this is a 16 zone input expansion card. So there were 16 zones on the main input on the main board, and I can add 16 more zones with one of these cards, and I can actually stack 2 cards on top of each other, giving me a total of 48 zone inputs off the main board. If I want more inputs, then I've got expansion enclosures. These guys add another 16 outputs and another 16 inputs, either available on this structured wiring mounting plate or in its own enclosure. Very useful on really big projects, or for projects that have multiple buildings, because obviously in a separate outbuilding I may have I don't really want to home run all the sensor cabling back to the main board. I can bring all the sensors from this building to this expansion enclosure, and it's only a single cable connecting the expansion enclosure back to the console port on the main enclosure. Or in a big building, it may simply be more cost effective to not have to run all that cabling back to one location. You can have some sub nodes for connecting up all of your zone inputs, and you get 16 more zone outputs as well for turning things off and on. And of course, you can connect your smoke detectors to this as well. So this can be up to 1,000 feet away from the main controller. So, and you can have 4 of these on a Omni Pro. So you can see it's a pretty scalable system. On the zone outputs, the actual outputs I mentioned, there's 8 of them on the main board and 16 on the expansion enclosures. The outputs are sort of 12 volt, so you can turn them on, you get 12 volt, 100 milliamp. You can turn them into proper relays with these little relay expanders where you can wire. This one's 8, so I can take all of my 8 outputs into here, and then I get a common, normally open and normally closed. Which I may need for certain applications. You know, some things like motorized blinds and curtains, you can just control those by wiring them into these normally open, normally closed type outputs. And they're good for up to 5 amps at 24 volts. So you can't put 240 volt through them. For 240 volt, you need to have a 240 volt relay hanging directly off the 12 volt output, and you wouldn't use these. The Omni controllers do come in their own enclosure that for UK security regs has a tamper on it. However, you can fit the controllers into these larger cabinets if you wish. These are called structured cabling cabinets, excuse me, and we use the structured mounting plates to mount them in there. You may want to do that if you've got a large system and you can put multiple things in here. You could put a controller, and we've got a shelf for a little battery for the battery holder, and then you might have an expansion enclosure, or you may have a controller and the hi-fi audio system you'll learn about later. So it's just another option in terms of mounting arrangements and cable management. This is a battery and a power supply, 24 volt AC power supply, and obviously various batteries. This one happens to be a 7 amp hour battery. You may need 2 of those if you want to have up to 12 hours of battery backup, depending on what your requirements are. Here, this is the keypad, or the console, it's also known as. You have to have one of these, at least one of these, on every system. It's four conductors back to the main controller, and just use standard alarm cable for this. 2 wires for power, 12 volt and ground, 2 wires for A and B. It's an RS485 bus, and you can have multiple keypads throughout a property. But like I say, you must have one. They're obviously battery backed up off the main battery, so if you have a power supply failure to the property, you can still disarm the alarm and access the system from this. But there's also key things you need to have from here for installation and setup that you can't get from anywhere else. Also available, it does look very nice if you use the flush mounting back box to flush it in. It does make it look very nice, so that's also available. Just a really quick whirlwind tour of the sort of things you need to hook up during the initial installation process. Just running through these key points here. Ground connection to a clean plumbing pipe or a clean earth, and AC power connection on these 2 pins here. And the battery backup, the red and black wires hanging off the board connect up to the battery, fairly straightforward. The console, that keypad, you can see it's on that top termination block strip. It is labelled console, and it does tell you 12 volt ground A and B, so it's pretty clear which wires go where. So all your consoles will connect together on those 4 terminals, and it's 4 conductors, and use alarm cable for that. The phone connection, with each controller you get this little junction box, and a little RJ45 connector, and this cable with the actual spade connectors that connect onto these 4 terminals. And again, it's labelled on the main controller that says telephone connection, and they're color coded, and the colors are actually on the printed circuit board for green, red, brown and grey. So that's pretty straightforward. Then this junction box, what you do is you connect your incoming telephone line from your BT master to the bottom 2 terminals here and here, which are actually labelled red and green, plus and minus. And then any other phones that you may have going throughout the property, you connect to these terminals up here, and that might go off to a an input to a telephone system, a PBX, or it might go to a telephone bus panel that then distributes your telephone around the house. Whatever, the bottom line is all the telephones in the house should hang off of here. The reason for this is the system can then seize the phone line if it needs to. So if you are on the phone and the system needs to dial out for you've programmed it, or for a security reason, it can grab the phone line and be able to then make the phone call. So that's quite important. Sounders, on the top connection strip, it is actually labelled on here for internal and external sounder. You typically have an internal sounder. Ideally, you want one per floor, especially if you have smoke detection. It is a requirement to have 80 decibels at the bedroom door for smoke detection. So you kind of need to have an internal sounder on each floor to ensure you will hear it if you're in bed at night and the smokes go off. And external sounders, again, you can have multiple front and back of the property, but most people will have one, but you can have multiple, of course. Smoke detection, we can support 2-wire and 4-wire smokes, but I would stick with 4-wire smoke detectors. They're just simpler, easier to use, and you can have more of them. 4-wire basically has 12 volt and ground power, and then 2 conductors for alarm circumstance. So when it's detecting smoke, then the 2 wires just wire into a zone input. That's the simplest thing to stick with, is the 4-wire. You have got 12 volt switched output off of here, so your power connections go off the switched outputs, and then your 2 wires go into zone inputs, and you can set the zone type to fire. With most smoke detectors, you leave them as latching, so if they detect smoke, they just carry on sound in alarm permanently, and then if you as the user want to reset them, you do so at the keypad and disarm the system, and then the switched outputs will then power cycle the smoke detector, therefore resetting it. So just to summarize there are 2 lots of 12 volt outputs. One's labeled switched and one's labeled aux. The switched ones will get the power removed and reapplied when you disarm the system, specifically for smoke detectors, latching smoke detectors. So that's quite important. Also, the system can actually be set up for confirmed smoke detection. So when they detect smoke, the system can turn the smoke detector off, turn it back on again, and if it detects smoke again, then it puts the system into alarm and the sounders go off and it tells you fire alarm. So that also avoids any false detections, which is quite a nice capability. Thermostats. So you can have up to 64 thermostats on an Omni Pro. So again, can handle fairly large systems. The LTE and the 2E only support 4 thermostats. The thermostats, we have a whole range of thermostats from wireless to wired. This is showing the wired ones, and they actually take one zone 16, and output 8. So you lose an output and you lose a zone. Again, it's an RS485 type bus, where all thermostats wire back to the same point, or you go from the terminals to the first thermostat, and from the first thermostat to the second thermostat, and data chain it, and then each thermostat is given a unique address to allow them to coexist on the same bus, and that's purely for relaying information back to the controller about current temperature and setting the heat set points, and indeed the cool set points as well. Hardware expanders, this is the daughter boards that live on the main controller in the top right hand corner. There's actually a special connector they sit on, and little standoffs that allow them to mount. Then there's a ribbon cable that allows you to mount another expansion board on top of it, so you can stack them on top of each other in the top right hand corner of the main controller board. The two-way voice module I mentioned earlier, there's a little connector on the left-hand side of the main controller and a ribbon cable. This will typically stick on the inside of the enclosure on the side panel and connect in to this connector here. And expansion enclosures, these are the big expansion enclosures that can live up to 1,000 feet away. These actually only require 3 conductors connecting them back to the main controller. They do require local power, and they have their own local battery backup as well. So you can have up to 16 zones and 16 outputs remote from the main controller, and only 3 conductors bringing it back to home. So I mentioned the console or keypad is very important. You've got to have one of these on each system. One of the reasons why you need one on each system is this is the only way to set the IP address of the controller on initial installation. And it's the only way to actually get hold of what's called the encryption keys. Every controller has a unique set of encryption keys, and nothing can connect to the controller without those encryption keys. Even the smartphone app, the software for programming it, even the touch screens, anything connecting to the controller has encrypted traffic using these keys. It's a very secure system. And there's only one way you can get to these keys, and that is through this console by entering into the installer setup menu. The hash key there's got menu written underneath it, so you press that to get into the menu. You can scroll down through the menus using the up and down arrows and select setup. Then you'll need to enter the installer code. Now by default the installer code is 1111, but of course any installed system will have changed the default installer code. But on a new system out of the box, that's how you get into the menu, and then you go into the miscellaneous menu, and from there you can then set the IP address of the controller. You cannot have a controller on DHCP. It has to have a static IP address, which obviously must be outside the DHCP pool to avoid any duplicate IP addresses. So that's where you set the IP address using the numeric keypad, and you can view the port that it connects on. There's never a need to change that unless you've got some really specific requirements. So leave that as default would be my recommendation. And then you can write down the encryption keys from that menu location, which you will need to put into touchscreens, the smartphone app, and the programming software. Just a note that if you take over looking after a system for a customer, the first question you want to ask them is, do you have the installer code? If they do, great. You can get in, get the encryption keys, upload the program, and carry on and support the client. If they don't have the setup code, there are no backdoors. There is no way in. You really need to supply a new controller to be able to take over the management of that project. PC Access is the software that we use for programming the control system and setting it up. The software is something that is chargeable. We bill for the software. You have to buy it. However, if you come on our Part 2 training course, which follows this, which I mentioned before is a 2-day training course, then currently we do free issue you a copy of PC Access in return for coming on the full training course. So the software, when you first install it, it will actually ask you for a security key. This security key is a word you type in, and then from then on all the project files are encrypted using that key. So you only get asked for it once at installation time, and all files are encrypted. So if anyone logs onto your laptop and steals your project files onto a USB key, they won't be able to open them without your security key. If you do need to share a project with someone, then you can export it unencrypted, and then you can email it. Don't try emailing an encrypted project file because people won't be able to open it. You have to use the export function under the file menu. Once you've done that, you can run up the software and it will ask you for a password, and the default password is password. And again, most installers will change this once they've installed the software for security reasons. And then to connect the software to the controller, that's now where you need to enter the IP address, port number, and encryption keys, and then you can connect to the controller over IP. That's the basic thing. You'll go through that process in the Part 2 training. I'm going to flip across to the software. This is the PC Access software here. It's got got fairly basic normal things: file menu for saving and file management, edit, normal sort of things. Communications and options are quite important. I'm going to go to options and network. This is where I enter the IP address of my controller that I've set using the keypad, and this is the default port. And then this is where you enter your encryption keys. You have to press show keys, this button here, and you have to enter the password for the software. And then you can see the keys, and then you can delete them and enter the keys for the controller and hit OK. So once you've done that, you'll notice as well we can connect via a modem or serial, but nobody really does that sort of thing anymore. Everyone connects via IP. Once you've done that, you can go to the connection menu, communication menu, and connect via network. I'm prompted to enter a code to prove that and this is where I have to enter the installer code to prove that I have the authority to connect to the controller. And I know I've connected to it because down here it now says online, and I've also got a fourth tab called status and control that wasn't there before. Just going to run through these tabs to explain what they mean. The setup tab obviously is for setting the system up. Initially, you do this once at the beginning, or if you make any changes. This is all really about telling the system how many thermostats there are. So if I click on thermostats, then you can see I can have up to 64 thermostats on an Omni Pro 2. And really all I do here is name the thermostats to give them sensible names and specify their function, whether they're heating and cooling, or heat only, or cool only, and basically their type. The ID gets set on the actual thermostat and gets learnt back in here. Of course, we've also got Zigbee thermostats, which you also set up the Zigbee parameters from here as well, but we'll cover that in another module. Lighting would be under units. So here I'm really just naming my lighting circuits that I want to have within the property. And again, on an Omni Pro 2, if you scroll down, I can have 256 lighting circuits on one system. Again, also audio zones get set. You name your audio zones, name your audio sources, and so this is, all the sort of setup stuff, and user codes for the alarm get set up in here as well, and you can name them for the different names of the users and so on. So the setup tab is all about setting up the system initially, and once you've set the system up, you'd obviously save your file to make sure it's backed up, and you can do all this offline, because right now I'm just working on the PC Access project file. Once I've set my system up, I would go to communication and write to controller. That will then write that setup down to the controller. Or if I'm picking up control of somebody else's system, then I could read from controller and read that information out of the controller into my PC Access project file. The next tab here is automation. This is where the magic happens, where I will be doing automation programming and setting up the automation functions. I'll come back to that in a minute. Event log allows me to upload the event log from the system. The event log automatically logs any security messages, but you can also write to the event log as and when you ever want to in the programming. And the status tab basically gives me information about the controller that I'm actually connected to. I only get a status tab when I'm connected to the controller. By the way, you can connect remotely to the controller. If you know how to set up port forwarding on the router, you can open up the port and provide the WAN IP address, or you're using dynamic domain name services, you can do all this remotely from the property where the controller is, which is very, very useful. So here I might be able to check, the system time and whether the battery's charged and the power's secure, and I could go to thermostats and I can see the current temperature and heat set point for each thermostat on the system, and lights, I can see the status of lights and security zones and what the status of they are. So I can see all the information about the system here, and I can change things as well. If I just double clicked on the thermostat there, then I might change its mode or its heat set point, and as soon as I hit OK, Currently its heat set point is set to 21. If I select heat set point and set it to 22 and hit OK, then you've seen that changes straight away, and that's just changed that on that thermostat. Going back to the automation tab, just want to give you a quick example of programming so you get a flavour for it, because we will go through in some of the later modules when we talk about heating. We'll come back to this software and show you the setup aspects of the heating aspects, and then the lighting module will talk about what you do in the setup for the lighting component. So we'll be coming back to this software throughout the next training modules. But just to give you a quick flavour, when I use the word programming, people tend to go, oh my word, that sounds pretty scary. But the programming that Leviton have made it very easy. It's all menu based, it's all drop down menus, so you don't actually have to write any real code. Just give you a quick example here. I click on this green button and go add new automation block, and this pops up a new dialog, and I've got triggers, conditions and actions on the top here. You always start with a trigger. Remember what I told you about event-based automation? It's always triggered from something. Here's all my triggers. I can trigger off just about anything: time, or someone pressing a button, or a door opening, or if the power goes off. I've got all sorts of triggers here. But I'm going to do an example, let's say, where let's turn the porch light on automatically if the front door opens, but only if it's dark outside. So I'll know the front door opens because I've got a security sensor on it, which is a zone. So if I select zones, then that lists down all of my security sensors that I've got within the property. And there cunningly I've labeled one front door, so I know exactly what it is. Secure means it's closed, and not ready means it's open. So here I can set it to not ready, which then means the door is open. I'm going to go straight to the action. The action, again, I can do just about anything. I could send an email, I could announce a message through the speakers, I could turn lights on, turn the audio on, change the temperature, whatever you like, you can do. What we wanted to do was turn a light on, and that's under control. And here it will list down all of my units, which is the Leviton language for lighting circuits, and there's my front porch. So I'm going to turn my front porch on. I could turn it on indefinitely, or I could select minutes and just turn it on for 5 minutes. So here you can see when the front door is not ready, it's open, turn the front porch on for 5 minutes. But we wanted to put a condition on there. We said we only want it to happen when it's dark outside. So I can click on the condition tab, and that brings up a dialog and allows me to, again, be conditional on just about anything. I could have that conditional on only when the power is on, which obviously would only happen, of course, because you wouldn't turn the light on if the power was off. But you get the idea. You could have it conditional on anything you like. We said we wanted it conditional on it being dark outside, and to make life really easy for us, there's actually a menu item that says dark. We know that when it's dark and it's not dark because part of the setup is you put the longitude and latitude coordinates into the system, and then the system knows when sunrise and sunset is in that part of the world, which is a really nice feature because, certainly in the UK, in the summer it's light till 10 o'clock at night, but in the winter it gets dark at 4 o'clock. So that way, if you have lights coming on at sunset, they'll actually come on at the right time, which is nice. So for this purposes, I can just click dark. So now when the front door is open and it's dark, the front porch light will come on for 5 minutes. Hit OK, communications, right to controller, and that programming is now in place, and that will start happening immediately. So that kind of gives you a bit of an overview of the system and how you get going and how simple the automation programming is, and hopefully you can now see how powerful this system is and how pretty well every home should have one. I'm going to wrap up this module now, and thank you very much for attending. Please tune in to the next module, which is available to you on the Aldous Academy. If you have any questions, you can always contact us on the contact details you can see before you. And of course, you can follow us on social media, on Facebook, Twitter, LinkedIn, and our YouTube channel. Thank you for listening, and I look forward to speaking to you again on the next module.